Module 1, Section 6, Objective 2. Writing exponents in expanded form as repeated operation. Okay, so basically, we're going backwards. And you can see from theirs, I'm not going to erase them because I don't want to write them out that many times. So 7 is your base, so we're multiplying 7s, and we need 5 of them. So 1, 2, 3, 4, 5. Multiply together. And you're done, because it says do not multiply. Okay, B is one of those that has 2 bases, so 5 4 times, 1, 2, 3, 4, and 7 2 times, 1, 2. Multiply them all the way across, and you're done. Okay, so C, we have a whole bunch of 3's, and specifically 7 of them. So there's 1, 2, 3, 4, 5, 6, 7. You're done. And D has 2 bases, so we're going to start with the 2's and do 3 of those. And now let's do 5 3's. And you are done. That's it. Okay, totally easy. Okay, now objective 3, we're actually evaluating whole numbers in exponential form by writing it as expanded multiplication. Okay, and you'll see what that means here. So if we start with 1 to the 7th, there's 1, 2, 3, 4, 5, 6, 7 1's times together. Now you have to actually answer it. That's the only difference. Okay, so 6 squared, like they said, is 2 6's. Now 6 times 6 is 36. 5 to the 3rd, 1, 2, 3 5's times together is 125. So squared and cubed are 2 shortcut words for the exponent of 2 and the exponent of 3. You'll hear those a lot, so those are ones that you want to remember. All right, D over here. 2 to the 6th power means 6 2's multiplied together. Okay, now let's do a shortcut. You can just go straight across. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. However, some people can't do that. So let's group them up. 2 times 2 is 4, 4 times 4 is, or 2 times 2 is 4, and another 2 times 2 is 4. Okay, 4 times 4 is 16, and 16 times 4, maybe that one's even harder to do. Maybe you want to just go straight across in your head. It doesn't matter, but the answer is 64. Okay, I am going to do E down here because I want to leave the teal one up there. So that's equal to 4 zeros multiplied together, which is kind of silly because 0 times anything is 0, right? And the last one here, F is 3 to the 3rd power, which means I want 3 3's. 3 times 3 is 9. Bring down the other 3 because we haven't used it. And now 9 times 3 is 27. So the answer to that one is 27. The answer to this one was 64. Answer to that one was 0. Okay, this one, we're just going to complete the table. And it talks about everything we've talked about so far, basically. So 2 to the 3rd, I don't know why they say this is a number. It's not. It's 2 to the 3rd power. Whatever it's equal to over here is the number. That's kind of interesting. But 2 to the 3rd, the base is 2. The exponent is going to be the 3, right? And now they wrote out 3 2's multiplied together, and the answer was 8. Okay, so we're just doing everything. Okay, so the next line, 3 to the second, 3 is the base, 2 is your exponent, so we're going to write 2 3's multiplied together, and the answer is 9. Okay, next row, 5 to the 4th power, base is 5, the exponent is 4, and you can see they have 4 of them over here. 5 times 5 is 25, 5 times 5 is 25, 25 times 25 is 625. Okay, on this next one, if we know the base is 6 and the exponent is 2, we're going to write it like this. So 6 to the 2nd power, and it means 2 6's multiplied together, which is equal to 36. Now this next one has 3 8's. So if we know the base is 8, the exponent is going to be 3. So you write it 8 to the 3rd. Now 8 times 8 is 64, and 64 times 8, so 48 add 3 is 51. 512. Okay, the next one, if we know the exponent is 2, and we know the answer is 49, two numbers that multiply together, they give you 49. Has to be 7 times 7, because they have to be the same number, right? So this is 7, and we would write it as 7 squared. And the last one here, if we know the exponent is 3, we're going to have 3 numbers times together to give you 27. So what does that have to be? And we did a problem earlier that was exactly the same number. So 3 times 3 times 3, or 3 cubed. And see, there's that problem right there. 3 times 3 times 3 is 27. Okay, this chart is talking about powers of 10 only. So 10 to different powers. Okay. So as you can see, they've started it. There's only one 10, so you don't have to rewrite it on this first row. Second row, there's 2 10s times together. So the third row is going to be 3 10s, and then 4 10s, and 5. One more. And 8. 6, 7, 8. Now I'm going to have to write these smaller because we need 10 10s. So there's 5, 6, 7, 8, 9, 10. Okay, so what is 10 times 10 times 10? We can use the zero trick. Okay, so we're going to do 1 times 1 times 1 is 1. And then we have 1, 2, 3 zeros. 1, 2, 3 zeros. Okay, next one. 1 times 1 times 1 times 1 is 1. And we have 1, 2, 3, 4 zeros. So can you see the trick? Okay, so if this is a 5, we have 5 10s, which means we have 5 zeros, which means, whoops, our answer is going to have 5 zeros. So you don't even need this middle row or middle group to figure out your answer. All you have to do is put 8 zeros after the 1 in this next case. So 1, and then 1, 2, 3, 4, 5, 6, 7, 8. Counting backwards and putting commas in, that would be 100 million. Now 10 to the 10th, I need 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Counting from the back, every 3. Okay, so this is thousands, millions, billions. So that is 10 billion. And we've already talked about what the pattern is, okay? So the exponent on the 10 tells you how many zeros there are after a 1.